My name is Deepthi, and I'll be the moderator for this panel. Thank you, everybody, for joining. Can we just maybe go in a circle and introduce ourselves? We could start with Carissa, that way we don't all talk at the same time.
My name is Carissa Petzinger. I currently am an integration engineer for Rondo Energy, and I mentor FRC teams. Haven't had a new team yet. I just moved, so working on that. And then also judge advise for First Lego League.
Jenny, if you'd like to go next.
Sure, I can go. My name is Jenny Stevens. I am a chemical engineer. I work in pharmaceutical and biotech predominantly now, although I've worked previously in chemicals and plastics. I am an FRC coach. I've been affiliated with several FRC teams now, including a new one where I'll be mentoring a third team. I've coached for two. I also judge for FTC and FLL, predominantly more recently at FLL. And like Carissa, who's already a judge advisor, I am training to be a judge advisor at the FLL level and FRC levels.
Nice. Kathy, if you'd like to go.
Yeah, my name is Kathy Giori, and I've not done any of that extensive stuff. I've toured an FLL team, an FTC team, and a FRC team through friends and getting tech women, emerging leaders who were here who wanted to see the US teams and what they're doing. So I've seen some of that, and I'm very, very, very impressed. And I would like to get more involved, and so I have some ideas on that. But I'm just sort of later in my career, and I'm leading my own startup. What we call a hobby startup. And I volunteer a lot of time to this project called MicroBlocks, which is a physical computing open source software tool, a nonprofit foundation, 501c3, which is a Scratch-like tool for programming, robotic sensors, all the physical computing, the sensing and the actuating. And so I'm pretty gung-ho on that aspect, and that's where I kind of focus my energy. But I would love to see it get used more in the, both robotics and science, sensing, all that kind of stuff as well.
Yeah, I think that's cool.
It's very cool. We have, and very low cost. And I think that, what FIRST does, if we could get that a lower cost model, we could get more of the global reach, because some of these small microcontrollers now are $4 or $5 or even less, some of them a couple dollars.
That's true. We've been setting up some microbits classes for our robotics team, and I can definitely say that they are more affordable than most kits out there, and you can learn maybe even more with them. So that's great.
Yeah, microbit is a very popular board in the US. It's less than $20. And the new Raspberry Pi Pico is $4 and then $6 for the wireless one. The microbit, though, has a whole bunch going on, and the Pico is just the microcontroller. You have to buy other things to connect to it.
Okay, well, I guess we can get with the next question. We can continue in the same order, I think, for the rest of the meeting. That way we don't get confused. But Carissa, I guess, what led you to choose your career, and what did it take to get there?
I kind of fell into engineering, really. My dad's an engineer. My mom's a math and science teacher. And so engineering is kind of really something I've always been exposed to over my childhood and even into, my young adult life. And when I was young, I really loved space and robots. I mean, that's kind of the classic, robots in space. So I learned a lot. I mean, I played with the Lego Mindstorms and all that probably 20 something years ago, when I was a kid. And that's really what kind of really started that. Like, I could see being like a robotics engineer or a mechanical engineer, and that kind of stuck with me. And when I was choosing like colleges, I was looking for programs that kind of fell into that realm. Once I was in college, it kind of like wasn't really sure where I wanted to take my mechanical degree, because I have a degree in mechanical engineering. And so I was kind of looking around, and I ended up working for a couple companies that did manufacturing, and that's really where I ended up, is in manufacturing. And I got to play with industrial robots and learning how to design for them and designing automation cells. And it took a lot of just kind of like small steps to see where that next goal was, and to just keep trying and keep moving forward. There were a lot of times where I just was like, I have no idea what I want to do. And then, you know, a couple weeks later, it was like, oh, that looks cool, I should try that. And then I would jump into that instead and start working on that. So yeah, kind of, I guess engineering's kind of always been in my life. And so it finally turned into a career that I really enjoy, with getting to play with actual machines on a manufacturing floor and working with parts and creating things to help people create things is really where I land. So
Nice.
yeah.
Oh, you can go ahead.
Would you like me to go next?
Yeah, go ahead.
All right. I have a slightly, and same end result as Carissa, but a different start. I have no engineering in my family. That was at least close enough to be able to be an inspiration. I have always been STEM oriented, and have to say that although there was some science in my family, that this was pretty unique, and I still kind of stand out in my family in that respect. I also lived in different places. We moved from the Northeast to the South when I was young. And I can say that encouraging minorities, including women, to be in STEM fields, science, math, engineering particularly, was actually not the norm. So I stood out. I can tell you stories about what it was like to actually be in environments where getting good grades as a girl, being interested in science and math, you know, I go back to, you know, decades. I have all kinds of stories about that. I can tell you when I pivoted from just science and math to engineering was right around middle of high school. I took an engineering class, an honors engineering class at a university near where I lived at that point. And I pivoted from, I liked chemistry. I'm a chemical engineer, as I said. I liked chemistry, but I didn't want to be in the lab, and I didn't want to just do experiments. And that's as simple as I saw it, basically in 10th grade high school. But I took an engineering class and said, oh, I get to make things and do things if I go into engineering. And while the science was awesome and the math was awesome, being able to add the technology and the engineering to it and actually do and create and make things was the draw for me. And I've never looked back. So through the rest of high school, college, my entire 30+ year career, and even though I went back and got an MBA in my early 40s in management and strategy, it was always to basically do different things as an engineer.
Okay.
I could have almost followed your path, because I think it was 11th grade, I was taking chemistry. I adored my chemistry teacher, Mrs. Rose. And I loved chemistry. And like both of you, math was pretty breezy for me. I had a father math teacher. But I didn't have any exposure to engineering and sort of industry, because both my parents were teachers. But I had to hide good grades, because that was embarrassing, and just among friends, right? But I got a scholarship right out of when I graduated high school, and the guy's handing me the scholarship money, and he's saying, you know, here's my card. If you're interested in a summer job, let me know. And it was a industrial manufacturing plant with electrical, hydraulic, mechanical, and sorry, but the mechanical drawings were something I couldn't comprehend, and the electrical was like math, and OR gates. It was digital. It was discrete digital logic back then. And I just thought it was so cool. So I kind of pivoted. Like, I had thought about going into college in chemical engineering, but then I said, electrical engineering. And one of the reasons I wanted to go into engineering was because I wanted to be an astronaut. And then I went and got a master's degree in electrical engineering, also at Stanford, because I needed an advanced degree to apply to the astronaut program. And then still got married and had kids, but long story short, VR helps with that now. You can just sort of imagine you're in space. So that's, that was my conduit for getting where I was. I think the commonality here is just a confidence in math. And that's where I think we got to get girls starting really early and getting that confidence right off the bat.
Yeah, definitely agree. Okay. Next question, also more about your career. I guess, what do you enjoy the most? Maybe some things you don't like, and kind of like a summary of what you do on a day-to-day basis.
Okay. So what I enjoy the most, I think for me, is getting to learn different methods of actually making things. So my previous job before the current one that I have, I worked for Tesla as an equipment engineer and castings. So I got to learn how high pressure die cast machines work and how parts go from a liquid metal to a formed solid and pretty much all of that. And then like how to actually treat the part when it comes out and then trim off all the extra metals and everything to make it a nice part that goes into your car. And before that, I worked as a manufacturing engineer for Generac Power Systems, where you're hand assembling quite a bit of parts to get through into this like nice little package. But then there's a lot of presses and things to like assemble an engine. And so getting to learn all of those is really fun for me. I love playing with machines. Machines are very simple in my head when I get to look at them and figure them out. And it always, I find it fun to learn a new machine and to get to create for that machine or improve that machine. The parts I don't like is actually probably dealing with people. I it's really bad, I know. Dealing with people is a lot harder for me. I'm not that much of an extrovert to some extent. And one of the fun things about manufacturing is that machines don't lie to you, whereas people will. And so it's always fun going out when there's an issue and you're like, what happened? And everybody's like, I don't know. And then you're looking at the machine and you're like, well, something happened because that hose used to be connected and now it's got this huge gape in it. And so that's probably the hard part for me, is like dealing with people's personalities and trying to piece all that information together. But once you kind of get used to it, you tend to figure out how everything works. And yeah, that's probably the harder part for me. On a day-to-day basis, currently, I basically sit in 4 different CAD programs pretty much at the same time, going through building what we call a federated model, which is like a master model of the product, and making sure that all of the integrated parts of that, so anything that was designed by engineers in-house, meaning people that work at Rondo, and then our contractors that work outside, so construction, electrical, ducting for airflow and all of that, and actual like architectural people to build like a building around our product, that all of their models come together and work with our in-house models to actually form the product that is going to be built on site for our customer. Right now it's a lot of meetings and talking to people, but the fun part about that is that I pretty much know what every engineer is working on within Rondo to some extent. And I see all the design changes and choices, and I can help with kind of seeing that overall picture and being the person to be like, hey, you might want to not do that because you're going to affect XYZ and that's going to push our timetable out too far. Or how about we do it this way because that's actually going to clear up a lot more issues. I can give all those suggestions. So it's more of a larger picture role versus actually dealing with the small like design challenges that a lot of the engineers I work with are working on. So yeah, that's kind of my day.
So Carissa, I'm going to pivot because I am extremely extroverted. So my background, I actually, over 30 years, I like doing a lot of diverse things. So I mentioned that I've always been a chemical engineer. Always had roles as a chemical engineer, but I've done so many different things in there. I've worked in, as I said, plastics and chemicals, and then pharmaceuticals and biotech. But even in there, I've done manufacturing. I've done manufacturing support, large capital projects globally. I've done, and then I moved after about, I don't know, halfway through my career, I moved into the quality space where I am currently. I've done that for the last, I don't know, 10 years or more. I like doing a lot of things. I think as an engineer, you can start out and you can find many, many ways to do different things. So I pivot constantly. And I do. I've moved a couple of times around the country. I've found ways to be locally based when I needed to be, maybe for personal reasons. I've found a time and a place in my career that I could travel globally, which I highly recommend. We are a global environment, and that experience is amazing. I've worked my way up through other projects and processes and titles, doing different things. But I have to say right now, so that's my background. I have to say right now, I'm working for myself. I actually started my own business. I've left, I'm still in the biotech and pharmaceutical space, but after 30 years, I moved about a year and a half ago into consulting for myself, where I basically can do any of those things at my decision to basically keep busy, to keep active, to bring that expertise and that experience to other companies that need it. It is an awesome place to be able to do that at this point in my career. It allows me the flexibility to be able to do things like coach FRC teams and judge and mentor other things, or judge FTC or FLL. So I love where I am right now. To answer the question about what I am doing right now, day to day, I am supporting a project over on the East Coast for a pharmaceutical company that is putting in a huge global installation of SAP Enterprise Resource Platform, the application to basically run their entire company. And I'm actually overseeing the quality aspects of that installation that should go live, fingers crossed, next May. What I like most, besides just being able to work for myself and bring all of those skills that I've learned over 30 years to the table, I do like the people part of it. I don't do well in isolation, and I like teaching and bringing that experience as well. So I completely just thoroughly enjoy when I did start to go traveling in projects globally, and I had to meet different people, different cultures, different experience levels. I find that fascinating. And it also allows me to bring a teaching or training component of my experience back to other people. So, but my day-to-day is pretty much a single project right now, focusing on a single client over on the East Coast. So I start my day very, very early with a 3-hour time zone difference back over there. And again, I then do robotics in the afternoons and evenings.
Well, gosh, I've also had a very long career, so there's too many jobs to list, but I will start with like probably my favorite job was right after college, where I was working at SRI International, and I allowed that interest in space to collaborate with my depth in electromagnetics. And one of my first projects was instrumenting with electric field mills these Learjets and flying around at Cape Canaveral to study atmospheric electrification from thunderstorms, which is very common in Florida, and try to develop a criteria to say when it's safe to launch rockets nearby these giant, cumulonimbus clouds, because rockets are essentially lightning rods in space, and they're bigger attractors to cause lightning. So that was a fantastic project. I also studied the dielectric materials that you cover satellites with and see how they discharge, because if they discharged too energetically, and we would measure the electromagnetic radiation, interference, they could damage electronics inside the satellites, sensitive electronics, the way they arc and spark. So I had some fascinating projects, and then that branched into, it was contract research, so that eventually branched into things. Then I started going into communications and GPS and digital electronics. fascinating. I highly recommend, an environment where you get to do a diversity of engineering things, because I could learn so much on the job, much more than college, right? So that was fascinating. And then I did the startup world, ran a startup in the .com era, .com.bomb, went through that. It was a fun learning experience. Without an MBA and with no managers, all engineers on the team, we flew high and then we crashed. So that was a good experience. And then I've worked for big companies, big semiconductor companies, and that's where you have the downsides. The great sides is I love working with intelligent people, where I'm always learning and enjoying, letting that brain work. And but the downsides are when you get, per your point, the bureaucracy or people career climbing, or people issues get in the way for doing good things. That's always annoying. And so, find the good people and then keep those good people as you move from company to company, because then you can follow, oh, now look where they are and they're doing this cool thing. And that's always been my pleasure, is I still keep connected to the most fascinating, remarkable geniuses you can ever imagine. So that's been my fun. Downsides also, just for women, is we tend to not find the sponsors and the advocates we need, the allies, because we're ignored, because we're uncommon in the tribe of mostly male dominated things. So I'd say that's also a displeasure of working, is brilliant women don't really get their due respect, I think, of other women. So find your tribe, find ways to get employee research groups, other things that allow you to build your community, your sponsorship. And before you join a company, look at how many women are in top level management. That's kind of one of the telltale signs. Let's see, what was one of the what do you like, don't like, and what was the third part?
What do you do on like a day-to-day basis?
Oh, day-to-day. Yeah. So that varied from like flying in Learjets to now, getting on a lot of Zoom meetings and collaborating. But because of my connections to really smart people, I now give back in strategy, like even young engineers, like the strategy of business, like what's the name of your company? If it's fun company, try to Google search that, or get a trademark on it, or get a domain name for it. There's like practical things you don't think of when you come up with naming a company. Like my current company I'm running, I just changed the spelling. It's like tricycle, but it's tricircle, and then circle is spelled differently with a Y, and then suddenly it's the #1 hit on a Google search, and it's the domain's available, and I can trademark it if I want to. So there's strategic things that you learn that's broader in the business spectrum. And then I have a lot of international connections as well. And sometimes I'm just editing their docs to make it sound more fluent, better translation. So I really admire young people. I was just doing that for a gal who's being written up in Forbes, and she's in her 20s, right? And she founded this project. She's doing AI, incredible things, but just a Q&A interview question, her answers, let you know that she's not a native English speaker, even though her English is amazing. So that would be day-to-day is different today than it once was when I went to the office every day.
Okay. Thank you for those responses. Let's go to the next question. So looking back now, is there anything that you wish you had known before you entered your career, or like any important skills you suggest people should have for your careers, things like that?
For me, I think I kind of knew going in, just based off of looking at my engineering classes, like there wasn't a lot of women mechanical engineers, at least not at my school. And so going into manufacturing, there's like even less women in it. So that kind of being comfortable with that was something I had to really get used to. Thankfully, my first job out of school, there was 2 other women engineers in the mechanical engineering department. So I got to really like see how that worked. And they actually would mentor me and help me learn what I needed to do. But then after that, like I've pretty much been kind of solo as the female engineer on my teams. So just being comfortable with the knowledge that I have and kind of finding that confidence and authority to be like, hey, this is how it needs to be. And trying to work with the people that are on the floor or in the machine shops and really showing them that I do know what I'm talking about and that I'm willing to learn from them as well, because I know I don't know everything and I don't want to pretend I know everything. But I've had a lot of experiences where I will tell someone something and they won't believe me. They go to my boss and he'll literally repeat everything I said and then they'll believe him. And I'm like, that's that's what I told you 10 minutes ago. So I don't understand the difference here. So I think just kind of wishing I had a little bit more exposure to some of that before I got into my career a little bit. I mean, I wish there was more women in the manufacturing sector, especially because it's not an easy sector to be in. But the skill part, it's really all the soft skills, knowing how to talk to people, knowing how to ask the right questions, being okay with not knowing all the information. I know sometimes I like to try to know everything before I do something, and just knowing that I don't have to know everything, but being willing to be like, hey, I'm stuck, I need help, asking those questions or getting that advice from other people who have been doing this a lot longer than me has really helped. Yeah, I mean, I wouldn't trade going into manufacturing. I really do enjoy it. And I think it's just one of those, like, I didn't realize how few women until I really started working in it. So.
All right, I had to get off mute. I had to shut the door to the classroom I'm in. I want to build on what Carissa just said. More and more, it's still a barrier to get minorities and girls in particular to stay interested in STEM subjects in school, and we have to address that. We're not able to do that, but those that get the science and math skills through middle school, junior high school, and high school, if we can keep them and get them into engineering fields, which is still very much a barrier. We just cannot break that 15 to 20% barrier of women in STEM type undergraduate degrees to move on. That aside, that's one issue. That aside, even if you get those skills from a scholastic educational experience and perspective, what you don't get a lot of is, because that's so intense to be in those technology and engineering majors, it's hard to get those leadership skills. It's hard to be able to get the exposure to be confident in yourself, to stand up for yourself. The flip side is, looking back, I didn't have a problem personally with confidence, but I think the flip side is make sure that you're not hard and brittle about being confident, that you don't tip over into I'm trying to prove myself so much and so hard. And it's so irritating that we have to prove ourselves in the first place that, you can go overboard. And it's sad that we have to talk about that, but it is true. We are judged differently. We do have a higher standard for a lot of people, as Carissa said. We'll be judged in ways that, somebody else isn't. We'll be considered too much. You're too loud, too talkative, too forceful, too anything, too smart, right? And balancing the need to still have to prove ourselves and our skills and being able to speak up for ourselves, but not going overboard, and being able to judge a room, judge a person, being able to, figure out how to approach any situation from a situational leadership perspective, I think would have, in looking back, coming out of, say, undergraduate, that type of experience would have been, and even just self-awareness would have been phenomenal coming out, right? With the end goal of being confident, be strong, but do it in ways that could be perhaps more beneficial to being part of an effective team. I think that answers both questions at the same time. Both parts to that one. I'm going to turn it over to Kathy.
Yeah, I mean, you both, I can tell by the way you described that we've all faced the barriers of being among the minority of not, you know, I think of the diversity, equity, inclusion things that you hear and belonging thing. For me, the most important thing is inclusion. If you're not in the majority, you may not be included and so forth. And why aren't you included? It's partly I don't know if it's a cultural communications thing, but what I learned the hard way, you know, in hindsight, is I could be brilliant technically, and I would try to prove myself. Like, let's take a huge corporate company, Qualcomm, and I came in through an acquisition of the Wi-Fi router industry, and I'd been in the open source community, and I knew, and I still know to this day, that open source software opens the gate for people to use the hardware. If you don't have access to the tools of building something with the hardware, you can't use it. And Qualcomm buys Atheros at the time, and they say, oh, but we do technology licensing, and we have to charge for the software, and we have to make it proprietary and only for our customers. I'm like, wrong. That's not how it should work for here. And I proved myself technically, but in hindsight, you have to speak dollars and cents. The higher you go in the food chain, you have to say, we're going to, and I finally, you know, here's an example. Here's a chipset that we have the open source upstream kernel driver. So we pick up the Linux kernel and the software just works for this chip, and I can just build something out of it. And guess what? It's not a supported piece of hardware anymore. So you're not paying any field applications engineers, you're not paying anything to support it. And yet it's selling millions of chips, and you're just cookie cuttering them out because all the development for it was 5-10 years ago. Right now, dollars and cents, you're making a boatload of money on just printing chips. So why, you know, and it's because it has software support out of the gate. It just works. It's mature. And so you have to know how to speak the business dollars and cents to get strategic moves across. You can't just say because it makes sense, because now the engineers can do blah, blah, blah. Just work hard to be open-minded, like even try to, I don't know, I should have done more collaborating with marketing and with the sales teams and I loved working with engineers, and I still do, but try to be broad in who you work with and how you understand and be able to speak the vocabulary of those different departments.
Right. Yeah, I definitely agree. I think you've also talked about this a little bit, but what advice do you have for high school girls who want to pursue STEM related fields? If you want to just add a little bit onto what you said.
Yeah, so I think my typical advice is find that one area that you are super interested in and hold on to it, but be open to kind of learning about other areas that may not be related, because it can always come back where you'll find something that you could use in that related field. But when you get closer to like looking at colleges and all of that, like it's okay not to jump straight into a 4-year university engineering degree, because sometimes you don't really know. Not all colleges are set up the same, so it's hard to like really figure out which field you might want to go into. So maybe start at the community college level, get some gen eds out of the way, but look at some of the tech courses that they offer with like robot trainings and machining and stuff like that, because it'll let you actually figure out if you like that thing versus sitting in a bunch of theory classes for, statics and dynamics and fluids and all that other stuff, and then realizing I don't actually like this. So like kind of maybe starting there. And if you really do already know, like, hey, I really want to be a mechanical engineer, then cool, jump straight into it. But if you're not sure, maybe start out a little at the community college, taking a couple different classes. It's not going to cost you as much money, and you'll actually find what you enjoy and want to make your career, and then jump into finding that 4-year degree if it's needed. You can learn a lot without having to go to college. So I always think that people should find something that they enjoy doing before they jump straight into the 4-year.
I'm going to build on what Carissa just said. So first advice for high school girls coming out, wanting to go into STEM, don't get discouraged, don't give up. They're going to face things. It's one thing to hear about that you're a minority in those fields. It's one thing to then experience it. It's one thing to go in and say, oh my goodness, look at my engineering classes or my science classes, and I am one of, 10 people. I am two, there's 5 women out of 100, whatever it might be. So don't get discouraged. It's be confident. Ask for help. If form your groups of like-minded people, make sure you have support systems. Totally agree with what Carissa said. Find out what you're doing. I've mentored a lot of younger engineers and scientists over the last 30 years. A lot of ones that come out of college with that shiny new degree. What I tell them, and they think that they have to have everything figured out. And so the next second best thing after being confident and sticking with it and don't get discouraged and don't give up is don't think that you have to have the next 40, 50 years of your career mapped out. There's a lot of ways you can use that engineering degree to pivot, and it's okay, right? So whether it's getting, like Carissa said, figuring out what degree you want or what subjects you're interested in, the same thing applies after you get the degree. It is okay to change your career field. It's okay to change jobs. It's okay to find a different way to be a chemical engineer like I did. I've lost track of how many different ways I've used that basic fundamental theory-based chemical engineering degree to get to where I was before I moved into my own consulting business. I think that's my main things is be confident, be strong, don't give up, and don't be afraid to try new things or pivot once you find that you do or do not like something.
I will, I agree with what both Carissa and Jenny said, and building off Jenny said of support groups. In hindsight, is another thing I saw working extremely well when you get a big enough organization, and there are things called employee research groups, ERGs, and you get like-minded people, like Qualcomm women in science and engineering, and you get the few people who are a little bit more like you support each other, and then try to get sponsors and learn from that. So there's in FRC robotics, you're doing that already still in school. You're forming clubs of like-mindedness to support your interest in your curiosity in robotics and learning from them. It's more than just robotics, it's everything around it. It's leading the outreach team, it's doing the marketing. You get like this small business startup-y type environment that you're learning from. Well, extend that through college and through your career of having groups that you can rely on each other and inspire each other and build off each other. And then just from an educational standpoint, right now, be as hands-on as possible. Like nobody likes theory and problem sets, like challenge yourself to take a problem set and turn it into something in the physical world. Like I did a project for science fair where I did an experimental, apply a magnetic field and watch the electron lights turn. And then I did the theory of the calculation of how much it did. And it was a simple concept of matching theory and experimentation. And yet it was like, really well-regarded thing to do. And it's much more interesting that way, 1,000 times. That's why I love physical computing. It's like, I can sense all this stuff. I can actuate this stuff. I can do it in the real world. And then the next most valuable thing is teach that next person younger than you those next grades younger than you, your peers even that don't know as much as you, teach other people, you will learn twice as much. So I applaud all the giving back to those grades below you, those ages below you. That's a really valuable way actually for yourself to learn and gain confidence.
Thank you. Okay, so now we have a little more questions focused on certain people. So I guess we can start with Jenny and Carissa. First question was, why did you guys join your respective robotics teams?
I'll go first. My reason for being on robotics is on this call right now. My daughter has been passionate about robotics since she was 8.5 years old. She started first robotics when she was in 9th grade and never looked back, and we have been involved ever since. So ours was very definitely a family endeavor because it started with my daughter, is now with my son. They've pulled us into this space for years now. And so we are a family of 4 that now do multiple ways of being involved in various robotics endeavors. But my reason is on this call right now.
My reason's a little different. I don't have kids, but I kind of joined because I've always been taught to give back, to volunteer and to find ways to help out different communities. And for me, I kind of got bored after work. After I graduated school, I needed something to fill my time outside of work. So robotics was just a perfect avenue because I could take what I've learned and then pass it on, like Kathy was saying, to other students, to other people, and kind of blossomed from there since it's been about 10 years now of volunteering in different positions and mentoring other students and even other younger engineers as they've graduated from high school and now college.
Yeah, I definitely agree with the giving back to the community. That's definitely one of the things we do with outreach as well. Adding on to that question for you two again, is there anything you've learned in the workplace that maybe you can apply to your robotics teams, or anything you've learned from FIRST that can also be applied to your job?
Yeah.
Yeah, that's a good one.
For me, it kind of answers both. But the creativity and the way that different teams solve the challenge every year, especially with FRC, because you are dealing with such large robots, and seeing how they use, simple like different applications of like rubber bands basically to pick up things or to stop something from moving to where you don't want it to move to, and stuff like that, like looking at all of that creativity, and then I can actually like take that and use it in manufacturing. Really, I can think about different ways to actually create something to work on a line that may be going down, or but the quickness in how to solve a problem as well. FIRST is a very compact timeline, and in manufacturing often your timelines are just as compact, especially if a machine breaks. You're immediately called out and you don't leave until that is solved, until that is either back up and running or everybody's happy with the solution of leaving it down until that next part comes in that you need to fix it. So taking that and just knowing how to think on your feet, but then also like, as like a competition, if your robot breaks on the field, how do you quickly fix it if you don't have that correct spare part and all of that? Those types of things, it translates really well back and forth between at least what I do in manufacturing and FIRST. So it's kind of, I learn new things from the kids in FIRST, with their creativity and how they use different things, and I can apply that to what I do. But then also learning, how to think quickly and move fast also applies both ways. So that's really it for me.
Yeah, so Carissa mentioned all of the engineering related side of things, which I think is amazing going back and forth. I would just echo that all the teams that I've worked on, whether it's FLL, FTC, or FRC in the last 6 years, that engineering design process is completely relevant to everything we do in robotics, in both ways, right? It's learning experiences both ways. To the point where, sometimes my robotics students will be like, really, Jen, you're going to tell us again about plan, design, build, and test? I'm like, yes, because you're going to hear this concept, no matter what it's called, over and over and over again if you go this route, for your career. But I also want to say that the other side of things is the organizational management, the entrepreneurship side of working. That one specifically, I say, comes back into FIRST robotics, or robotics in general. I find it very easy for teams to get caught up in the robot side, which is extremely critical. But the project management skills, the leadership skills, things that you can do for fundraising, finance management, all of that's the other side of a well-functioning FIRST organization, really hard to learn, and bringing that back in from the workplace and trying to teach at least the basics of those types of skills are something really valuable that can be brought back in from a work environment, industrial, academic, back into a FIRST team. So I think I was going to add on that layer to what Carissa said.
Okay. Kathy, this question is actually for you now. I just wanted to ask, how was your involvement with MicroBlocks? Like, how has it helped other robotics teams? Because I know you've actually been helping our team a bit with the whole purchasing parts and all to set up our classes that we're planning. But yeah, I just wanted to see how you may have helped other ones.
I would love to do more. I would love to see, FIRST seems like such a fantastic organization. And so my involvement in MicroBlocks is like, okay, MicroBlocks makes it easy to start early, and we want kids to start early, really early, before they have any concept of even boys and girls. Like, you got to catch them early, and then they have the vocabulary, they have the confidence, and they know they can make things, programmable things. So I've even start really early with, this is from last Christmas, but with my granddaughter, I made a MicroBlocks based smart Christmas tree. And you probably can't see this. Oh, there's no audio. Let's see. But she clicks buttons and gets different patterns. And so, so I made little button presses and sliders and LEDs, and then the ornaments change colors based on what she does. So she's using it now, but she's 4.5. She was 3.5 last year. Now she's 4.5. By the time she's like 8 or 9, I can teach her how to program it, because MicroBlocks is so, drag and drop, scratch like for physical computing. So the way I see, FIRST is you can get that pipeline started early so that you can get more girls. Like, what's the percentage of girls to boys in FIRST? I bet there's more boys. Yeah. And so,
yes.
And
yes.
and then creativity, girls bring this diversity of how to solve the problem, or what problems to even solve in different things. In physical computing, you can be interested in animals or plants or climate, or there's just so many things you can learn and do. And so that's why I'm gung-ho about how do we marry these tools that let you start earlier and engage with confidence. And it allows anyone, like some people step back because there's problems and they don't understand how to solve it. But MicroBlocks being the only blocks that is live, is you click the LED on button. If it doesn't go on, well, then there's a communications question or a hardware, it allows you to debug things live. And so I've seen kids, I've taught workshops, summer workshops to girls coming in as high school freshmen girls in the underserved schools. So they're mostly Latina and stuff. They come in with zero programming experience, and I teach them MicroBlocks, and they're programming these Adafruit Circuit Playground Express and doing LEDs and sounds and colors and sensing things in one-day workshop at Santa Clara University, and they've never programmed before, So it's I think it's a great tool to get going, and then it goes very deep. You dig into the libraries, you've got full HTTP, UDP, MQTTP, you can do amazing things under the hood. And so even as a grandma, I'm programming with MicroBlocks. I'll never go back to the stuff that's harder to use. So I just I think
Please
giving back
send this
and teaching
information.
the
That's
next
amazing.
generation, you know, it's like, imagine yourself being able to give back and saying, yeah, my grandma taught me how to do smart Christmas trees and stuff. So
Hey, yeah, I've also experimented with the boards and all a little bit, and it's very entertaining. I like,
yeah,
you
it's
don't
fun.
need any experience on the programming side. And I mean, we started building little robot cars to get going with our like class curriculum, and it's amazing because you can see them work and move so easily, and you can teach it so easily, and people have fun. So yeah, definitely.
I've got a new, just new off the press too, is there's this new Octo Studio that you can program little you know, apps on your phone. One of our community members kind of reverse engineered the Bluetooth exchange between phones and intercepted it, so we can go phone Bluetooth to microcontroller. And so now we can use their 5 like triangle, heart, there's like 5 shapes, and we could send those as our forward, back, left, right, and stop commands. So you could actually like learn to program a phone to control your robot.
That's impressive.
Really cool thing.
I have to look into that more. Okay. Jumping back to Carissa and Jenny. When and why did you guys join the Society of Women Engineers? And I guess what was your experience with it and any specific role you might have?
I first joined in college, did it for several years through college, out of college, it probably my first role in my first company. Got out of it for a little bit, probably maybe in my late 20s, early 30s, got back into it as I was advancing up. I've presented at SWE conferences several times. Not as active now where I am in my career, although I am still a member. My daughter on the call was a SWE Nexter all through until she graduated high school. So I think I got into it because it was very much professional society, one of the stronger ones at the university that I went to, and we got into it along with a couple other ones that were discipline based. So I've pretty much over, what is that? I'm going to put an age on myself now, 35 years or so. I've gone in and out of SWE. I'd say the majority of that time. There are some times I've lapsed, but I think it was a college experience that got me into it. And then it was when I got back into it again, at maybe the middle of my career on to now. In all cases, it's been for networking. It was for training. I think the conferences are phenomenal to be able to both network and do training, and the educational just the support in general, I think, is probably what keeps me in the Society of Women Engineers. But that's how I got in, was college.
For me, it was a little different. I knew about SWE when I was in college, but I didn't actually join until about 2 years ago. So basically in the middle of my career. And I primarily joined basically because working in manufacturing, you don't have a whole lot of other women to really talk to. So it was a way to basically network and find other women, hopefully, that were in manufacturing. SWE is a lot bigger. So, I mean, it's not just manufacturing engineers or anything like that. It's a wider range of women who are engineers. And so it was just kind of more of a trainings. I mean, that stuff, I haven't been to a conference, but their classes and stuff are really good, and it just kind of gave me something else to help keep me learning, but also like a network, which is important. And I've been a part of also like ASME, which is the Mechanical Engineering Society. I've been a part of that since college, and I used to be very active. I'm not as active anymore, but I'm still a member. And it's really just about the networking and finding like-minded individuals to help keep you moving forward.
Yeah, I would agree to that. I've done several other professional societies for exactly the same reason. So whether it's American Society for Quality or International Society for Pharmaceutical Engineers. It's about, you know, AICHE, which is American Institute for Chemical Engineers. There's a bunch out there. Finding the like-minded people with the same passions, the networking, the educational opportunities. There's a lot out there. Society of Women Engineers is just a phenomenal organization to bring in that space and to encourage everyone, not just women, because it's open to everyone, to basically recognize the challenges that minorities and women face in STEM fields, to be quite honest.
Okay. Adding on to SWE next, actually, is there anything you may have learned from SWE that can be applied to your job or your robotics teams that you're part of?
I don't know something specific. I mean, I went to a lot of conferences for SWE. I went to, and then I presented at several. It's been a while, but I presented at several. I don't know that there's any one thing that stands out because they offer so much in the way of training and education to be able to do that. I think it's more of generically, whether it's SWE or any other organization that's out there, when you join it, just soak up the knowledge, right? You can find topics. There's so much extra material beyond just the book learning that is now offered and available. It wasn't even the case, you know, go back 30 years ago for me when I was starting my career. Just take advantage of it, whether it's SWE or SWE Next or any of these other professional societies or affinity groups, your sponsors, your mentors, whatever you find, just soak it up, soak up that knowledge, listen to the stories, take the classes, watch the YouTube videos, watch the TED Talks. There's just so much opportunity to get that, to get into that available knowledge that just wasn't the case 30 years ago, right? I think that's more what I would say take away from SWE is use it as the phenomenal resource among other phenomenal resources that are out there that just they're so easily accessible now that weren't accessible even 10 years, 20, 30 years ago.
Yeah, I can with Jenny on that. Some of the stuff I've learned, I mean, SWE has a phenomenal mentor network and also has a really good soft skills like career advancement guides and stuff. So that's helped me, especially learn to be a little bit more advocating for my own career. Because I kind of went into my career going, well, my boss is going to see how good I work, but I don't always remember that. They don't remember everything that I've done. Like I have to like push that forward a little. So finding that and really like understanding that advice of how to talk to your boss about advancing your career and getting to that next step and everything. I mean, that was probably really helpful. I think I watched a video from SWE on that like probably 6 times before it finally was like, okay, I can do this. Because it was just one of those like, wait, what did they say again? Like, how do I bring that up and how do I make myself feel comfortable talking about how to progress my career and get those promotions to the level I know I should be at. So that kind of really helped. And then just the networks. I found that out here, at least in California, there's a really strong SWE network, and being able to, you know, when I'm thinking about maybe changing my job or looking at switching kind of what field I'm working in, knowing that there's people out there that I can reach out to quite easily and be like, hey, do you know of any jobs in this area? Or how could I switch to this field? You already work in it. What's my best like way to go about doing something like that is really helpful. And then, yeah, just the knowledge aspect. They have a huge database of knowledge that like you can't really find anywhere else sometimes. You may be able to find it, but it may not be specific enough to what you're looking for. So, yeah.
Okay. Kathy, jumping back to you now. So you mentioned that you are part of Tech Women and you've had experience spreading STEM to other countries even. So could you maybe add on to that, talk a little bit about it?
Yeah, but before I jump into that, I just want to say I'm a little jealous of the SWE because one of my problems is I involve myself in too many organizations. And so I do this SWE summer camp, this Get Set program, and then IEEE Speakers Bureau, and I do that. And it's just like, okay, but then I don't have enough of only have my SWE summer camp tribe of a few women who are sounding. So I'm a little jealous, I should get back and do some SWE stuff. But Tech Women is phenomenal. It's funded by the U.S. Department of State, and they take volunteers as mentors. And when we get to work with these international women who come from Central Asia, Africa, and the Middle East. And although we mentor them, we learn as much from them as we mentor them. It's incredible learning their culture, their knowledge. They're emerging leaders. They're brilliant women. They're hand selected of being really premier in their countries. And I've had the opportunity to go to their countries a couple times because they have the U.S. Department of State funds these delegations. Well, they don't fund our travel. We have to pay our travel, but they set up and run the whole delegation. You go for a week. I was just last spring in Kazakhstan. And before that, I had so many connections. I also went to Kyrgyzstan and Uzbekistan. And I'm particularly fond of microblocks and physical computing because I think that if we can get economic stability and opportunity in the rest of the world, the brains of the youth everywhere in the world are just as smart. I'm convinced. Their ideas, their ability to do, but they don't have the opportunities that you have in the Bay Area, let's say. And so if we can bring them those opportunities, and I've donated thousands of dollars of hardware, either some from myself and some from other hardware companies, and any way I can. And I go there and I teach workshops, sometimes directly to kids, sometimes to makerspace staff, or sometimes to older, the tech women themselves that are back there, or teachers. They'll bring me into schools. And it's so valuable. Sometimes I need translators. One time I needed 2 translators just to learn the basic. But I think it's a phenomenal thing. And through Tech Women, I had the opportunity to have some emerging leaders here who are involved in the FIRST robotics from other countries visit FIRST in the Bay Area. And then one of them remembered that I had a connection in Morocco. And they said, after the earthquake, we really want to, a Palo Alto Curiosity Robotics, we really want to give back, not just money, but how can we give like hardware and kits and, make some educational kits. And sure enough, one of my emerging leaders, now fellows, was volunteering in the mountains where the earthquake hit. And she's now helping them with their kits so they can have an actual direct connection between students here and students there. And I made another connection in Tunisia with some FIRST robotics, and it's just, it allows the youth across international boundaries to communicate with each other and be inspired by each other. And I just think that's phenomenal. The cultural bonds is what will make these wars go away. Building bonds, don't build animosity. So we can do that with technology and education. I'm hopeful.
Okay, believe it or not, that is all of the questions that I had for you guys today. Thank you so much for taking time to get on this call and answer these questions. And I can't wait to be able to put this out on YouTube so that other people can watch this and other females can watch this and, listen to your advice, maybe even become inspired by it. So, thank you for joining on this call.
Thank you for organizing it.
Yeah, thank you.
Inspired
Thank
by
you.
the next
It was a
generation.
pleasure.
Rock.
Good night, everybody. Bye.
All right. Good
Bye.
night.
Bye.